Hey everyone, today we're going to be taking a look at a specific case of integration by parts in which you have an exponential multiplied by a sine or a cosine. So the first thing I'm going to do is I'm going to set up u equals e to the 4x and dv is going to equal sine x dx. Okay, now if you want to set it up the opposite way, where u is sine x and dv is e to the 4x times dx, that is workable, but I do think the common convention is to set up u with the exponential. So that's what I'll do for this video. So let's continue. We're going to have du is going to equal 4 e to the 4x times dx, and v is going to equal negative cosine x, right? Okay, so now we have our original integral is going to equal uv, which is e to the 4x times negative cosine x minus the integral of v du. So that's negative cosine x, put that in parentheses, times 4 e to the 4x dx. Okay, and what I'm going to do is I'm going to simplify this integral on the right here. So I'm going to say this is plus 4 times the integral e to the 4x times cosine x times dx. Okay, so now we just need to figure out this integral. So what we're going to do is we're going to set up a second a second integration by parts, where u equals e to the 4x. So I guess that's the same from the last time, right? And this is going to be still e to the 4x dx, but dv changes to be cosine x, and v is going to equal sine x. So I forgot the dx there. Okay, v is going to equal sine x. So now that I have the integral of e to the 4x times cosine x is going to equal, sorry, I forgot the dx. E to the 4x times cosine x times dx is going to equal uv, which is e to the 4x times sine x minus the integral of v du, right? So that's sine x. I'm going to stick the 4 outside. E to the 4x dx. Okay, so here's the important thing to recognize, because at this point we are effectively done. We just have some arithmetic left to find our answer, because our original problem asked for e to the 4x, the integral of e to the 4x times sine x dx, and here we have sine x e to the 4x, right? So we've gotten the original integral back. So now if we just substitute back into our original equation, we're going to have an equation with just one variable, which is the integral that we're trying to solve. So let's just do that and finish off this problem. So I'm going to write it. What I'll do is, yeah, I'll write the full thing. So, okay, so our integral of e to the 4x sine x times dx equals this equation, right, that we have here. So that is e to the 4x, sorry, let me rewrite that, e to the 4x times negative cosine x plus 4 times this integral, which is equal to this, so that's e to the 4x times sine x minus 4 times the integral of, sorry, I need square brackets here, don't I? Yeah, I need brackets here. So I have 4 times this entire thing, 4 times the integral of sine x. Actually, I'm going to rewrite it with the e to the 4x first. E to the 4x sine x dx, right? Okay, so now I just distribute the 4, right? So that's e to the 4x times negative cosine x plus 4 e to the 4x sine x minus 16 times e to the 4x sine x dx. So I'm going to add the 16 times this integral on both sides. So now I have 17 times e to the 4x sine x dx equals e to the 4x times negative cosine x plus 4e to the 4x times sine x. Okay, so now I just, I'm going to factor out the e to the 4x and I'm going to divide by 17. So my final answer is e to the 4x divided by 17, and then I should just have 4 sine x minus cosine x and plus c at the end. Okay, and let me just check the answer key that I have. Okay, yeah, so this is the correct answer. Okay, so my closing thoughts for this is, first off, it doesn't matter which ones you set to be which ones you set to be u and which one you set to be dv. So I think by convention, you should just stick to having u equals e to the 4, or u equals the exponential, and dv equals the sine or the cosine, and just stick to that and only practice using one consistent way. Okay. Secondly is the importance of like seeing, I think the big picture ideas, which is that you start with this integral, and after doing an integration by parts twice, or after doing 2 sets of integration by parts, you end up with the integral. You get it back, right? So we got it back here, and then you're going to substitute it back in to a prior equation, and that gives you enough information to solve the problem. So I think if you can recognize those 2 ideas, then you should be in good shape to solve these questions with some practice. Okay, so that's all for this video. Take care.